Okay, so we're going to get started with our last panel, Biohacking Human Health. Our moderator for the session is going to be Robert Kaplan. Robert is a faculty member at the Stanford School of Medicine Clinical Excellence Research Center. In addition to that, he served as the Chief Science Officer at the U.S. Agency for Healthcare Research and Quality and spent a lot of time at the NIH. Joining Robert are going to be David Hausler, Professor of Biomolecular Engineering and the founding scientific director of the Genomics Institute at UC Santa Cruz. Yi Zhao, Professor of Molecular, Cellular, and Developmental Biology at UC Santa Cruz. Vanita Bajorie, Chairperson of NICO Cables. And Alexander Ioannidis, Assistant Professor of Biomedical Engineering at UC Santa Cruz. We'll let the panelists get started.
Thank you very much, and thank you for having us. This group had a planning call, which was very exciting. We got together and talked about what we want to talk about. And we decided that what we would do is pull together a discussion about what each of us does and then try to connect it over a common issue. So the panel represents expertise in biomolecular science, computational biology, neuroscience, clinical endocrinology, and public health. So it's a wide range of issues, but we thought that what we'd like to do is to talk about how this emphasis on AI is affecting all of these sciences. So this is primarily an academic group that's interested in advancing the sciences and international collaboration. And so we want to talk a little bit about how AI is sort of uprooting all the science that we do. And so we decided that we're going to, excluding myself, talk for about 4 to 5 minutes. And in fact, I was thinking about how I'm going to enforce this. So I have a little card here that says, "and in conclusion." And so if people go over too long, I'm just going to flash this at them and have them read "and in conclusion." Then we're going to go from there to a discussion among the panel members, and we're hoping to leave about 20 minutes at the end for open discussion. So, David, do you want to kick off?
Sure, I'm happy to kick off. I'm David Hausler. I'm the director of the Genomics Institute at UC Santa Cruz, and we have been thinking about revolutionizing medicine and our understanding of human health for decades. It was an enormous step to first sequence the genome and understand how the proteins that make up our body are actually generated and what the differences are between people that make them more or less susceptible to disease. And we started out with a very high expectation 25 years ago when we first posted the initial draft of the human genome on the internet that very soon medical advances would follow on this deeper understanding of the genome. It turns out, and we should have seen this in the rearview mirror now, it seems clear, it's much more complicated than we anticipated. It turns out that, so the human body is the product of 4 billion years of evolution, of evolutionary struggles of our ancestors on this planet. And it is the most life forms that have evolved are the most complicated things we know of in the entire universe. You are the most complicated thing we know in the entire universe at this point. And to understand it to the point of actually being able to really treat you completely as an individual is a daunting task. Now we hope, the theme of this conference is that we hope maybe AI can help us with that. And I think it could. I think there certainly is the potential. We heard many references earlier today that, well, AI is exceptional. It can speak hundreds of languages, and humans can't do that. Yes, in a sense, the cells that make up your body, the trillion cells in your body are all working in a language. They're working in a language of biochemistry that has evolved over these eons to a point of complexity that truly is beyond the human capacity of any one brain or any one human, even a small group of humans, to completely comprehend. Can we truly comprehend the complexity of what's happening in our cells? And as a complex system, could we truly, with confidence, predict what an intervention would do on an individual? Well, we haven't really faced that problem to the full extent now. We've been always trying our best. And the goal has always been, well, you know, if we train doctors as well as we can and they go out and they give it their best shot, that's got to be good enough. Can AI ultimately aid these doctors to do dramatically better? Yes. Okay. We can certainly climb up that slope, doing much better than we can now with our limited knowledge of biology. But to actually fully understand biology, we would have to do experiments and science at an unprecedented scale. I'll just leave you with one analogy because I'm probably close to time. We all heard a lot about today, and we hear it every day, all day, about large language models and how they've somehow mastered the human languages. Human languages are very complicated. Our conceptual understanding of the world as reflected in our language is very complicated, but it evolved over about 3 million years. Your cells evolved over, as I said, 3 or 4 billion years. Now that probably makes them 1,000 times harder to actually understand in a fully predictive way than human language. So we are, at minimum, dealing with a problem that is 1,000 times harder than the problem that AI has just tackled successfully. We will not get there with anything less than 1,000 times more power in terms of not just compute power, but primarily data. The other thing that we had with LLMs was that we had immediate access to give AI an unbelievable amount of tokens. These are words, all the words spoken and recorded on the internet. But we can't record from these cells. We still can't record at scale what cells are actually doing in the context of human tissue. So we have an amazingly hard lift in technology to gather the data that it will take to train the AI. If you think about a paragraph of text, we got to where we are on a few billion paragraphs of human text. At minimum, we're going to need trillions of correspondingly dense and important measurements from cells. So think about RNA-seq or whatever your best technology is about interrogating cells. Think about that and doing it from 1 trillion cells. The current AIs, they have access to data from a few billion cells that much. So 1,000-fold more, and yes, you might see some spectacular advances.
Thanks, David. Vanita, can you go next and just briefly introduce yourself and then tell us.
Hi, I'm Vinita Bajoria from Nico Cables, Calcutta, India. So thank you so much for having me here. And David, that was wonderful, the way you spoke about humans being the most complex people to fathom and the most complex organisms to fathom. And since I am the only one who will be bringing a layman's perspective to this panel of experts, I know I have to keep it really simple. So I'd like to start by saying that imagine if the next big breakthrough in human health did not come in a pill bottle or on an operating table, but on your personal dashboard. Now, just imagine your body as a living map, giving early warning signs, guiding targeted interventions, even letting you redesign your biology, all before disease ever sets in. Now, that is the power of biohacking. Since I've been told to speak about biohacking, so this is the layman's perspective on biohacking. Now, why does this matter? This matters because non-communicable diseases like diabetes, cancer, heart diseases, they account for almost 71% deaths globally. In India alone, they account for over 6 million deaths per year. Now, these are not just statistics. They are a silent tsunami. And yet, our healthcare system remains stubbornly reactive. We wait until until symptoms appear. And then we unleash expensive surgeries, medicines, machines. But unfortunately, by the time we reach the hospitals, much of the damage is already irreversible. Now, what biohacking does is it flips the script. Instead of waiting for illness, we engineer wellness. Instead of hospitals being step one, they become step last. Now, at its heart, biohacking is taking ownership of your biology through data, through experimentation, and most importantly, through intentional lifestyle design. Now here, I would like to pause and give an example of Dr. Anjali Kumar, who is a diabetologist, dietitian, and an MD who runs a clinical practice in India, in Calcutta. So she has seen over 3,000 patients with over 11,000 consultations. And she maps her patients, each patient, across 128 data sets, including current health history, family genetics, diagnostic tests, gut microbiome, body pH levels, stress levels, even gene-food compatibility. And then she treats them not with overnight fixes or with miracle pills, but through personal interventions like across 4 areas: correct exercise, correct diet, breathing techniques, and targeted supplements. And the results have been absolutely amazing. Almost 97% improved diabetes markers, 80% lost weight, 87% reported reduced anxiety and stress levels within 3 months, and almost all of them improved digestion and even got rid of chronic pain. So these have been small data-driven tweaks leading to huge transformation. Now imagine this at scale. What if we fuse Silicon Valley's innovative DNA with India's data-driven biohacking? Now, India on one side has huge diversity, scale, and clinicians like Dr. Anjali Kumar who track hundreds of data points per patient. Silicon Valley, with its pioneering breakthrough in AI, genomics, biotechnology. Now, if we can bring them together, we can actually start a global health revolution. So this biohacking is actually not about adding years to your life, but about adding life to your years. Now, using these small tweaks, we have this opportunity to turn personalized care into to completely change our lives and take healthcare out of hospitals and into our hands. Because the next few, especially in the near future, healthcare will not be belong to hospital corridors, but will be in our hands, in our habits, and most importantly, in how we intentionally design our lifestyles. So,
Thank you so much. So, Yi, do you want to talk a little bit about neuroscience? And
So I will talk about. I'm a neuroscientist. I like mostly academic, and so my particular interest is how the experience shape our brain, the experience such as learning and memory, such as stress like we are facing every day, and such also new environment like you're moving from different countries. So we are interested in how the different kind of experience shape the brain and how the brain help us to adapt it to the new environment. So in this panel, I kind of want to talk about a few different things. So first, I think we talk about the AI a lot. There are AI used for product design, the AI used for everyday life. But like Yi mentioned earlier, there's also AI used in science. And I would love the people to push people to think and what kind of, while we are talking about science, we are talking about something new, something pioneer. And if our AI data is based on the common middle level information, how can that really push for science, or they really have limitation there? So that's something I want to discuss, talking about the AI used for scientific development and the standardization of those kind of informations. And the second, since I'm a neuroscientist, the other things I really want to talk about is mental health. We talk a lot about health, we talk about biohacking. You can hack genetics, you can hack metabolism. But the biggest issue the world is facing now is actually the mental health. The studies in our college students conducted a few years ago, and I think it's done in Michigan State. And they are just track the college students, the mental health conditions. And they were saying that when the student in the third year in college, 30% of them are clinically diagnosed as depression or anxiety. If our top of the country people, like 1/3 of them is really mental disorder, what kind of world are we dealing with? And I kind of think can AI help that? Maybe the biohacking is not only at the genetic metabolism, exercise, changing our habit level. Maybe we should think about how we deal with the brain health. I think that's the things not only as a scientist we are curious about, as an educator, as a mom have a kid going to college this year, it's always on my mind. Yeah, so that's it.
Thank you. Sure. Alexander, thanks. And tell us a little bit about data science and some of the things that you're working on.
Thank you. Really interesting to hear everyone what's working on. I work mostly in computational precision health. It's related, of course, to biohacking, also very much related to genomics and understanding the cell, as David was talking about. But I'm looking at a much higher level. So let's take all the data we can, and here we want data from hospitals, clinical records, all your imaging data, and all the data, right? Your genome, if we can get it. And let's see if we can predict your health outcomes. Let's see if we can predict earlier that you need a treatment so that you can get it when it's more effective. Let's see if we can predict something about better donors if you're trying to get a bone marrow transplant. It's a project I'm working on right now. Who's going to be the perfect match? What's a good digital twin for you? So what's your health outcome most likely to be in 10 years, and what changes should you make? How can we summarize this? All of this is powered. In the past, we would use machine learning. Now we call it deep learning, and now we call it AI. Although AI means a lot of things. I'm not talking about ChatGPT. I'm talking about creating our own neural network architectures. But how can we summarize patient clinical records, right? So this is another big problem we're working on. You've got 50 pages of clinical records if you've been through the health system for a number of years, especially if you have a problem. And you're coming in and you've got an anesthesiologist, and he's going to be your anesthesiologist tomorrow. He's got 5 patients. He's got to review all of their files, 50 pages each of them. He has to do it in the evening, on Sunday evening. He's going to come in on Monday. He doesn't, I've talked to many of them. They don't read, obviously. Well, this they can't, right? There's important information there about what might happen in that operating room when you're under, right? Maybe you're going to have low oxygen. It's in there, but it's not easily accessible. AI can find it though, right? It can summarize those records pretty easily and give him bullet points of what he wants to know. So there's really exciting things, I think, going on in medicine with AI. And it can also help, if we have your genome sequence, we have your HLA as a part of your genome, we can tell who's the best match for your bone marrow transplant. And in fact, that's very easy now. It used to be invasive, it was kind of scary to be a donor. Now, actually, just so everyone knows, it's not invasive to donate bone marrow. It's like it's more than a blood draw, but not much more. So, consider it, right? Because you can save a life. But that means there's a large pool of people who could be used as potential donors, right? So let's find the best match, right? And that's something we can do by looking at the genome and learning from the matches that were successful in the hospital. What did they look like? How did their DNA match? And then we can predict in the future. So this is all stuff that I'm really excited about. And I think we have a lot going on now. So.
Great. Thank you. So, and by the way, thanks to everybody for staying right on time. We're doing well. One of the questions I wanted to ask the group is, in a meeting like this, I think one of the products that we'd like to see is international collaboration. But we have a lot of roadblocks that, data standardization, protocols, maybe regulatory stuff with privacy protection and so forth. How do we get around that to promote international collaboration in these areas? Please.
Yeah. I think there is a lot of collaboration happening. Like, for instance, AlphaFold, when it predicted all the known protein structures in 2021 and made it open source, then we had hundreds of millions of people accessing it. And actually, that really changed medicine. And even today, for example, like what Alexander was talking about, matching of organs, now we have printing of organs. So which also, of course, cuts across geographical boundaries. And this is AI for global good. So now, in the very near future, we won't even need organs to be matched. And to Yi's point also, with the help of AI, we have been able to find the gut-brain axis, which is so much being talked about now. And now mental problems have been found that even problems like Alzheimer's are related to the gut. Our gut microbiomes through the vagus nerve, they travel. And so I think that area also is, this kind of research is helping people globally.
Good. Yeah. David.
Yes, I agree. In an earlier panel, we recalled the image of the Earth rising over the moon and our sense of unity as a species. We definitely need that in medicine, and we need to think of that in terms of our genomes. So we all come from the same tree, the tree of life. We are all on branches of that. And many people are very afraid that their genome information will be used against them in some way. So we have a huge political and personal perception problem. And it's not an unreal possibility in some ways, but the benefit of actually sharing the information about our DNA with each other far exceeds the actual risks. It's hard to convince people of that, but it absolutely does. And as we are able to use that information better, if we can get beyond this fundamental feeling that our genomes will somehow inevitably be used against us, then we have a huge vista of possibilities, unimaginably, really, truly great possibilities in medicine. But the fact is, we haven't made much progress on that. Countries hold their DNA. They don't want the DNA of their citizens to leave the country. Hospitals want to protect the medical information of their patients against adversaries. We pass law after law about privacy and blockades on sharing of genomic information. I've been very frustrated. I was one of the co-founders of the Global Alliance for Genomics and Health. It is the most powerful organization right now in terms of international standards for sharing genomic and other medical information for the purposes of scientific advancement for the benefit of all. And I've watched all the politics play out for more than a decade now, and it's slow going. So for all the reasons that we heard about on all the previous panels, there is a lack of trust. And until that's overcome, we won't be able to learn as much as we could from our genomes. We won't be as healthy as we could be.
Totally agree with you, David.
So I think we are running into a century of big data. So we were trained to do a very small, like one question, one experiment things as a scientist. But nowadays it's very difficult to do that. But to build up the collaboration, I think there are a few levels of things we need to think about. We need to think about the willingness as a scientist to collaborate with each other, which I attend so many international meetings. I think people want to collaborate, and people do have big ideas, so it's not a lack of willingness. But the second level, we have to think about policy level. But the policy is really hurting us. Like from like the U.S. China is a big issue, and what the copyright is a big issue. So there are a lot of issues. People are scared. A lot of people are scared to initiate new collaborations, particularly with China, with Asian countries. I don't know with India whether it's also running into the same issue. So I think the policy needs to be changed. And because scientists are funded by either industry or government, and some places people need to stand out, no matter you're from the government, institute or from the industrial institute companies, I think people need to stand up if you're willing to fund this kind of research. And the third, actually, lying in science itself is standardization. It's a really different. We are all too selfish. This is all problem. We do Python a cell, we use different solutions. We have a genome, maybe like different groups recorded different ways. I'm a neuroscientist, so we have so many people to record thousands of neurons, not even from human brain, from mice brain. We try to decode how the brain works. But there are a few thousand labs, or even more than that, to do similar kind of work. People record different cells, use different behaviors, use different indicators, different electrode. Everyone uses their own things. So like there are huge debate, who is right, who is better, which indicator is better, my behavior is better than your behavior. So I think we need to standardize. But I do see hopes. There is a international brain labs recently built up, and actually the different labs across particularly Europe and the US, they are labs donate their own time, their own money without any government funding, any industrial fundings, try to build up, and they were doing they standardized the behavior, they standardized the recording method, and they were trying to compare notes with each other, so that making the data more trustworthy. Actually, I got recently involved in an NIH-funded grant, basically try to standardize some behavioral studies. So I think there are hope there, but maybe at this moment it's not enough. So I think as a scientist myself, we should willingly to put into the time and money and myself's effort to contribute, to be agree with each other, not just to focus on publish a few nice papers, get a few awards, but more like how do we standardize. But for the people who are in the power of changing the policy, we really need help there.
Yeah, I totally agree. We need more standardization. I would love to see, for those of you in technology, like an IEEE for genomics, where we have so many different things. It's crazy.
Right.
I think that's one of the great things the Genome Browser did at UC Santa Cruz, is provide some sort of standardization of alignments and different species, and that's why it was so widely used. As people know, standards really open up an industry. So I wanted to build off David's comment on data sharing, since we're talking about international collaborations. I think it's incredibly important when AI comes into the room, because we need huge data sets to train, right? Anyone who knows, if you're training machine learning, AI models, you need really large data sets. And the large data sets are going to come from different places. So that's a really important place where we need to have more collaboration. The UK Biobank, just to give you an example, I mean, we'll talk about Britain, since it was brought up, right? And, so they have the biggest, I would say right now, biobank that's accessible to all researchers. So they have whole genomes for about 500,000 people. They've got all their medical records, and anyone around the world can get access to that and do research. And it's really pushing the health of their own population, because the papers that are coming out are about how to do a better job treating British people, right? But everyone's doing it because that's the data set that's available. And speaking of resources, I mean, one of the incredible things that India has is just an incredibly large population. I mean, it's, you just think about it, but it is an incredible resource. I've talked to more and more people, and the number of training samples you need to make good algorithms for health are very large. So actually, 23andMe, for those who are familiar with this consumer test, just released a paper at NeurIPS, and they show that they don't even get improvement over just a linear model for predicting, based on the genome, your health outcomes until they exceed 1 million individuals. So you don't even get an improvement over a line, or a linear model, until you have 1 million people. And in India, you have more than 1 billion. So, that is a big deal. Because, the US, what do we have? We've got, I don't know, now more than 300 million.
300 million.
That's 300 times the minimum you need to even do better than a line, okay? So yeah, I mean, collecting data, having some sort of standardization program, genomes and medical records is going to be incredibly valuable going forward.
Yes.
This is going to be the material that goes as input into creating these models.
Great.
And the U.S. does not have the will or the political whatever it would take to actually share millions of data points. We will never be able to compete with England, or we would not be able to compete with India in terms of genomic data sharing. There's way too many factions and distrust and broken politics here. No way. You could get it together in India if you had the will to actually transform medicine with your population and everyone working together.
No, Alexander, to your point, and to your point, David, there's definitely, there's what you said, David, was that everything is a trade-off, and data sharing in the field of medicine has far more benefits than disadvantages. But having said that, and of course it's so counterintuitive that on one hand you want great AI that can really come up with great cures and breakthroughs in medicine, and on the other hand you don't give it the data that it needs to learn. It's like wanting your child to pass his exams without giving the books to study from. But having said that, of course, one country has data, the other has technology. So it has to be a fair partnership, and it has to be a win-win. It can't just be one country, gives all or takes all. There has to be a partnership. And during COVID, it was proven that countries could come together and fight a global pandemic. So I'm sure that all these diseases which are becoming, really big, and it's affecting people globally, will definitely need to be tackled globally if we can all come together and build global partnerships which are absolutely fair and square.
Thank you. We only have about 10 minutes left, and I wanted to make sure we had sufficient time to hear from people in the audience. So,
I'm going to start here.
Thank you. Thank you so much. You have such great perspectives. I was wondering, there's so much hype about AI in healthcare and in all of your fields specifically. What's actually real? How is AI helping you do something differently? What should we be excited about that's tangible, whether it's behavioral health, wellness, precision medicine, at all?
Yeah, immediately, it's doing a great job at summarizing text. I'm sure people in this room are using it that way, right? You can drop a scientific paper and you get some nice bullet points. You can see how this is valuable already for these complex medical records that, as I mentioned, the clinicians don't have time to go through. So I think that's already happening. And you can also see a really interesting company that's really kind of exploding right now called Open Evidence, which is sort of, for doctors, if they want to query AI, they want to get, what's the right dosage to give to a patient who's 5 years old for, this condition. So yeah, there's things like that that are happening very rapidly.
Also in diagnostics from images, AI clearly exceeds human capability in calling a medical diagnosis from an image. And these different types of modalities. It could be It could be regular image, it could be an MRI, it could be, whatever. We face an issue of doctors now having access to very data-rich examination procedures. Maybe they use a $1 million machine to come up with some information, but it's not in the purview of a simple human doctor to get all of the information out of those billions of bits of data in just that 7 minutes they have to talk about to talk with the patient. They need this extra interpretation, and they're getting it, and it is potentially very powerful.
Great.
Now
Thank
I
you.
think-
How about,
Okay.
yeah.
Go over there. All right.
Oh, I'm sorry.
I'll make it quick. I'm Dr. Kshirsagar, and we do fundamental AI research as well as applied research. The biggest problem with AI today is most of it is developed by computer scientists. And there have been additional inspiration. For example, there is physics-inspired neural networks, which brings differential equation physics. I came up with biochemistry-inspired neural networks and generative AI, in which people will take inspiration from the mechanisms in those sciences. So my question is directed to this neuroscience professor here. I'm aware with Indiana U and psychologists participating in defining the new generation of AI architectures that don't simply need trillions of data, because we need normal data, and we need certain anomalies, so you can reduce the size of the data sets. So you can even do it in US if you do it right. So to me, my question is, how many AI companies have come to you, could you help us understand how neuroscience works and help us put that in the AI architecture? Being this Silicon Valley, the premier thing, Indiana U is doing it. How many have come to you?
No, none of them. So, I want to answer this question and last question a little bit. For science, I think Yi mentioned earlier, and I don't think they are helpful. There are a lot of people, there are a lot of top profile journals published, like you have to almost have AI to get it published. You almost have to AI to have the grant funded. But in reality, I don't think it helped. So there are very beautiful algorithms helpful with I do microscopy, do image analysis, but for eyes, day and night things, and they couldn't recognize. And there are a lot of things that do behavior, and they can chop the behavior using the AI with a 3-millisecond event. And for our human brain, we don't know what it means. They give us beautiful drawings, beautiful things, and we couldn't make sense of it. Maybe, and there are, even for the training the doctors, there are just a recent life cycle paper published, AI did improve the diagnosis of corneal atrophy. I couldn't pronounce that word very well. But after the doctor used it for 6 months, their capability of making the correct diagnosis decreased dramatically. So I'm not sure. So as a neuroscientist, I kind of feel the electronic brain, the computer is electronic brain, so it's kind of we're thinking we're mimicking brain, but I don't think AI is mimicking our brain. I think I think it will be helpful tools. It will be very helpful tools to do a lot of things. I don't argue against that. But I feel like if we really want to find the human intelligence, make it really from human intelligence to artificial intelligence, we need to rethink the problem. Maybe we really need to understand the brain first, then to apply.
So
I agree with you. It's doctors with AI versus doctors without AI, right?
Curiously enough, we grow small bits of human brain tissue in my laboratory, and we actually try to train them to do things. If you've ever tried to balance a yardstick on the end of your finger, this is quite hard. You have to constantly move it to keep the yardstick standing up. And we just published a paper, which is the first cerebral organoid. This is lab-grown brain tissue that was able to solve that problem by reinforcement learning, which is exactly the same technology they use to train AIs. So I find it compelling and very profound now to ask the question, to what extent are the AIs that we're building like our brains, or to what extent are they completely alien species that thinks differently? For the most part, they are very alien to the way our brains work, but they share some commonality. Unfortunately, we understand neither at this point. We do not understand how our own brain works, despite incredible effort on the part of famous neuroscientists like we have on this panel. And anybody who's built an AI will also tell you, and we heard earlier confirmation of that, that they don't really understand how this language model works and why it answers the way it does. So we are in a crazy situation in terms of the evolution of humanity and how we learn to control this planet, and we learn to create something that is doing things beyond human capacity, and yet we don't understand it. It doesn't understand itself. It doesn't have human capacity. And I think there were also some earlier comments about the danger of that, and I take this extremely seriously. If we go on our current trajectory of racing towards superintelligence without any really clue as to what superintelligence might be, but it's just a buzzword, and you know, Alibaba's going to have it before Meta, and we are setting ourselves up for an incredible disaster. Do not build something that is more powerful, more capable of manipulation, and these things are really good at manipulating you. Do not build something that has capability far exceeding human capacity unless you're confident that you can control it. Do you believe that if Mark Zuckerberg builds superintelligence, he will maintain control of that superintelligence? Or that President Trump will step in and control that for the betterment of humanity? Do you believe that for a second? Then don't let them be reckless at this point. Understand what superintelligence is before you build it.
I totally agree with David. I think we need to be intentional about what we are building, and we have to know what we need before we just go out and build it. We need to become better humans before we even think of making better artificial intelligence. So we need to work on our natural intelligence, absolutely.
We need to pay attention to what actual intelligence is.
Totally.
You know, we had two people who are waiting patiently. Maybe we can hear these two questions together and we'll give quick responses. And
You cannot combine. Mine is different.
pardon?
Mine is totally different. Okay.
Yeah.
So I must tell you that I want to share with you some good news and also some good opportunities. So some of the people here know me. This is Naren Bakshi. For last 7 years, we've been running an NGO here as well as in India to solve some of the problems you're talking about. What has happened in the last 20, 30 years is unimaginable. We thought the best healthcare will come with the combination of Eastern philosophies and Western science. So we started this thought, and today, Vinita, was surprised you coming from a cable company talking about what you were doing. I was flabbergasted. So today, just think, yoga is everywhere. Meditation is everywhere. Intermittent fasting is everywhere. And I am personally, you'll be surprised, I'm a real example of reversing everything. Until 2011, I was diabetic, I was sleep apnea person, I had hiatal hernia, and on and on and on. I have zero by changing all this combination.
Great.
So my question now, the opportunity that I'm talking about, is that we now have figured out that there are only 3-4 ways we are going to move forward. We have to educate the population about how to live better. We have to inspire them by role models, including me. The third thing has to happen, which is we have to provide them support, community support, societal support. That needs to happen. So my hope is that all of us will try to form a community whereby health becomes problem of a community, not just an individual. So Vinita, please tell me why and how you know so much about this. Coming from cable company, I looked your LinkedIn. I could not find any connection.
Thank you so much. That was really humbling. But I'm really impressed by how you've healed yourself. And I so agree that we speak about intelligence, artificial, natural. The divide is just blurring. And in the quest for intelligence, we have actually lost our wisdom. So now we should actually be looking at becoming wiser, not more we can just offload the intelligence bit and become wiser. And like you said, our old philosophy, and I must confess that I am a Vedantic student, a keen Vedantin, so I totally believe in philosophy, yes, and the more we are moving towards the future, which is getting more and more artificial, it's actually taking us back to our age-old wisdom, which is what we are. And we have been so busy trying to get intimidated and threatened by something that we have built and something which is artificial, that we have lost track of who we are, and it is we who have created that. And once we discover who we are and we can see the powers we have, we'll totally stop getting threatened. And I think that will solve all the mental depressive problems, because they all come because of the insecurities, anxieties, when we completely lose track of who we are. And the more rooted we are in our own wisdom, be it age-old wisdom or whatever the philosophical leanings, so the less we start getting threatened. And the minute we become a better person, we create better communities, we create better societies, and we create a better world.
So we are out of time, but this gentleman's been waiting patiently. Why don't we hear the question, and then we'll sort of we'll discuss it as we go.
Thank you, Professor. Finally, I got a chance. And I'm working in this domain at the investment level, due diligence level, in multiple domains. I'm going to pick Professor Zhao's area of neural science and so on. The gut biomicrome to the brain neural the communication between them, it has its own native code, if you want to use that word. And I have devised, what to do, how to do, about, etc., to decode the communication that happens to say, I want coffee now, or how it communicates. I'm hungry, whatever it is, right? So is any research happening in your organism? Then same with the other UCSC professor.
There are a lot of research on that direction. Yeah. So, but it's a puzzle. We don't know. Even my own lab, we are doing. Yeah. So there are both sides. But so even NIH a few years ago began to find the interception, basically how the peripheral feeling. Yeah.
Yeah.
I want to collaborate and do the.
That will be fun. Yeah.
All the details.
Oh. Yeah. And unfortunately, we're out of time, but this is just a great topic to bring out to the cocktail hours. So I want to thank the panel and thank the audience for staying all the way to the very end today.